Okay, so today's lesson is actually going to be a slightly different perspective on the exact same stuff that we did in the previous lesson. So we learned that what we call f prime of a is going to be this limit, and we have two ways of writing it. We can write it this limit as x goes to a of f of, I think we write a minus f of x over a minus x. And then there's the other consideration where instead of having two variables, x and a, where one is getting close to the other, we also just set this up to be the limit as h, and that is an not great h, limit as h goes to 0 of f of a plus h minus f of a over a plus, sorry, um, this comes from plugging in a plus h minus a, but we don't write it like that, right? Because that simplifies down to just h in the denominator, right? And both of these give us the derivative at a. But this function is kind of suggesting that, or sorry, this function notation, the way that we write this, is kind of suggesting something is happening that relates to functions, right? Well, the idea here is I pick a value for a, and I get some result. I pick a value for a here, and then I get some result, right? This always ends up turning into some value, either one of these. Technically not always, there are sometimes the derivative doesn't exist, but I pick a number a and I get a number, and that's the derivative, right? Some other number b. Well, this idea of start with a number and then you get a number on the other side is the idea of a function. I pick a number for my input and I get an output. So it turns out that yes, the derivative is a function. And that is exactly what we've been writing with this notation, right? F prime of a value x is the derivative of x. Now, we write this a few different ways. So the way that we write it here, right, just f prime of x, that's just the derivative of f, right? Well, another way to write it, it keeps undoing what I'm doing, and I don't know why. Another way to write it, we'll say the derivative with respect to x of our function f of x is one way to write it. So this d over dx is an operator, right? Because what's really happening is I'm starting with some function f, and then I do something to it to get f prime, right? We've done something to the original function. So in math, we call those operations, and the operation that we just did on f was taking the derivative. So this is derivative with respect to x of f. What do you mean with respect to x? With respect to just means what is my input variable, right? So saying the derivative with respect to x is just establishing, pointing out that your variable is x. So we write this a few different ways. Sometimes we write it like this, d over dx, and then f to the beside it, right? We also will sometimes write df over dx, and that is the exact same thing, just a different notation, right? It kind of looks like a fraction. If I have like 3 halves times 4, sometimes we may write this as like 3 times 4 over 2, right? So it's kind of the same thing happening there. Now, another notation that we write is this big D f stands for the derivative or differentiate. So that's something worth saying. Differ. Oh, I cannot spell differentiate means take the derivative of. So again, just can I take the derivative of this is the question of is it differentiable or not? Can I differentiate, right? It's just a new word that's saying the same thing. Differentiate means take the derivative of. So this notation is take the derivative of f of x. They may even only write this capital D f. And if they want to make it clear what the input variable is, the derivative with respect to x, they'll write this x as a subscript, and they may even write like this f on the inside there. Um, they get really crazy sometimes, and they'll write f and then this subscript x, and that tells us the derivative with respect to x again. Um, or our favorite way of writing it, f of x, f prime of x, I mean, or maybe just f prime. It turns out all of these are going to be the same thing. And sometimes they'll just replace f with y, right? We like to write y equals x, so it turns out this is also dy dx, or y prime is the same thing. Um, yeah, very good. So right now we're just throwing a lot of notation at you to say these are all the different ways that we write the derivative. However, um, these in the middle here are not going to be used in this class. So we introduce them to you now, but we're not going to ever use it again. So a class like differential equations is absolutely going to use these notations, but hey, we are not in differential equations yet, right? So we're going to ignore these for the time being. Um, they exist, we're just not messing with them at all right now. Um, yeah, also, the fact that we have dx here, right, becomes really important in the context of multivariate calculus, right? So if I have a function f with two variables, x and y, then saying derivative with respect to x could be different than derivative with respect to y. But guess what? We're not in multivariate calculus, so we don't really care about functions that look like that. So realistically, the with respect to part is not super important to us right now. Further out on the horizon, sure, that is important to know. So it is good to get in the habit of saying derivative with respect to x or df dx, right? But it's not really going to matter that much for a very long time, unless you count like 2 semesters as short. I don't know. You'll care about this in maybe 2 semesters, but right now, not quite. So we're going to be derivative with respect to x for a long time. Okay, so these are all the different ways that we write the derivative of a function. Um, and it turns out the WebAssign has already been making you find derivatives, right? If it says find f prime of a, where a is some number, and then you get some function in terms of a, well, that is just the derivative, but you're having a as your input variable. So you have already been finding the derivative as a function if you've been doing those questions on the WebAssign. So very good. Good job. Um, yes. So it turns out that is essentially all of 2.2. It's just introducing a bunch of notation and saying, by the way, I've been writing this using some kind of function notation, and it turns out I've been doing that because it does make sense. The derivative is a function. Differentiating is an operation that gives me a different function. Technically, it sometimes can give you the same function, but you know, you get a new function at least regardless. Okay. So yeah, this is 2.2. It's kind of short, more derivatives. Um, yeah. So that's it. Good job.